is that this is our way of remembering how electrons are needed to fill each shell. So what we're talking about there is that 288 rule. Now, we're kind of lying to you here, okay? This 288 rule doesn't actually exist, but it works perfectly for the first 20 electrons, first 20 elements. Now, the 288 rule obviously only goes up to 18, so we actually end up, for potassium and calcium, we end up with an additional 2 on the end, right? So if you were to look at calcium on your periodic table, you would see it is in the 4th period, aka the 4th row. It is 2 across. So its first shell is 2, second shell is 8, third shell is 8, and its final shell has 2. So what we're going to do today is we're going to draw some electron configurations. I really like this lesson because it's a lot of drawing, okay? So if you like art, you're going to love this. If you don't like art and you're like me and can't draw to save your life, it's going to be very challenging. So we're going to start off by drawing sodium. So can everyone put their finger on number 11 of their periodic table? So find number 11. Okay. Now, what is the symbol for sodium? Na. So in the center here, I'm going to write Na, and I want yours to be about the same size as mine. Okay? About the same size. Now, when we look at Na, remind me, if I draw a little box up the top here, I had Na, above it I have the number 11, and below it, do we just give you 23? What do we give? What's your number? 23. Great, 23. So when we're looking at this one, the atomic number is this number up the top. That's the atomic number. And it tells us how many protons there are. But in an atom, the number of protons is the same as the number of electrons. So how many electrons am I going to draw? 11. And we're going to follow this 2882 rule. So let's start. In the first shell, we have 2 electrons. And these electrons, okay, because this first shell is so small, these electrons like to exist on opposite ends. Otherwise, they're packed in. So they like to have a bit of space, right? So in the inside shell, they're always going to be drawn like this, a little bit spread out. When we get to the second shell, okay, they then are inhabiting a bigger shell. And because they're in a bigger shell, it means that they really want a friend to hang out with. Okay? And so what we do is we draw these next 8 electrons with a friend. Okay? And I like to represent electrons as E with a little negative symbol so that I never forget they are negative. Okay? And then I'm just going to connect these all together. So how many electrons do I have all up right now? 10. How many do I need? 11. So how many more do I need to draw? 1. And so this 1 exists all by its lonesome on the outside shell. It can look in and see all of those other electrons having a friend to hang out with, but this 1 electron is pretty lonely. Okay, it's the sad outermost electron. Okay. Next, let's have a go at drawing chlorine together. So can everyone put their finger on 17? Yeah, number 17. And you'll see if I draw another box up the top left-hand corner, I should probably do that in red, we have the symbol for chlorine is Cl. It is number 17, and the weight we've given you is 35.5. Okay. So what we're going to do now, what do we write in the very center for when we draw electron configurations? Great, we write the symbol, so Cl. And as a reminder, let's do that little tick on the L so that we make it really distinct from I. And capital I, so when we talk about iodine. Up next, how many electrons are we going to have in chlorine altogether?
17.
So, I want you to have a go at drawing these shells. I'm going to pause my screen so you can't see the answer. I want you to have a go. You've got 20 more seconds. Five, 4, 3, 2, 1. All right, so our answer for chlorine should look a little something like this. Okay, we have 3 shells in chlorine. The first shell has how many electrons? 2. The next shell has 8, and the final shell has 7. Does that add up to 17?
Yeah.
Yep, so we're all happy. Okay, so what we're going to do now, okay, and I'm going to give you a blank piece of paper to do this, is we are going to have a go at drawing the electron configuration for the first 20 elements. Now you're probably thinking, oh my goodness, this is the most boring thing I've ever done. I actively hope so. Okay, we are going to get through this, okay, and we are going to practice all of them so that when you get to, say, a test or an exam or anything in between, you have done so many of these that it is just another thing that you are capable of doing. So I'm going to hand out a piece of paper now. Let's do these ones. Go at some practice. Let's have a look. You've got some practice examples that we've just had a go at. What is the relationship? So what is shared or not shared between the number of electrons in the last shell and the atom's position in the periodic table? Okay, so there are some keywords that I'm going to be using here. The last shell is what we refer to as the valence shell. So for hydrogen, this only has, if I draw a very bad hydrogen here, it's only got 1 electron. So its only shell is its valence shell. If I draw lithium here, it has an inner shell and it also has 1 electron in its outer shell. This is its valence shell. So if I highlight here, that is the valence shell for hydrogen, that is the valence shell for lithium. If I drew, say, sodium now, okay, electron, electron, I'm just going to switch to X's just for speed and time here. This next shell, full, and then we have 1 final shell back again. This final outer shell, okay, that I haven't even drawn properly, is the valence shell. Okay. So, you tell me, all of hydrogen, lithium, sodium, where are they found? Can you find them on your periodic table for me, please? Where are they found? In the first group. And in the first group, how many valence electrons are there in each case? 1. So, the relationship between these is, and I like to write in dot points in science, there's no need to write long, windy responses, is the number of valence electrons is equal to slash the same as the group number. Now there's one exception, okay? In all of our first 20 elements, there is one exception. Can you find an element that only has, or that has a different number of valence electrons to its group number? It's to do on the right-hand side of the periodic table. There's one element. So, in group 8, the noble gases, okay, what number is group 8? 8, okay. Helium, how many electrons does it have in its outermost shell? 2, because it only has 2 electrons. So the only exception to this rule is helium, because it's in group 8, but it only has 2 valence electrons, 2 electrons in its outermost shell. Okay, that's the only exception. So, as we've just discussed, the last area, or the last shell, is the area that is responsible for many of the physical properties of an element. Okay, now this last shell, we just said, it is known as the valence shell. I'm going to highlight that because that terminology is so important. Okay, so important. When you're writing responses, it's really important that we use the correct terms. And so instead of saying the outermost shell, I want to hear the word valence. Okay. Now, the number of electrons in the valence shell is determined by the groups. That's what we've just written. The number of electrons in the valence shell is determined by the groups. Now to answer those questions from our prior page, if I scroll up very quickly, okay, the first question, why are metals slightly different from one another but essentially so similar? Well, it is because metals have valence shells that are more empty than full. Okay, this is an important idea for us to understand because in a minute we're going to start adding them together, these metals and non-metals. Non-metals, okay, have valence shells that are more full than empty. Okay. So what do you think metals and non-metals like to do? They like to join so that they can complete their valence or outermost shell together. So, our examples that we're going to look at very quickly. When a metal combines with a non-metal, okay, both elements end up with complete valence shells. Okay, so both elements end up with complete valence shells. So, sodium metal reacts with chlorine. Okay. Why does sodium only lose one electron in this case? Why do you think? Have a look at sodium on your periodic table. Why does sodium only lose one electron? Yeah. What? Because it's in group 1. And what is the same for all things in group 1? What do they have? Great. One electron in the outer shell. So sodium only loses one electron. Why only one? It only has one valence electron. Okay? It only has one electron in its outer shell. Now I want you to find chlorine on your periodic table. And if you have a look for chlorine on your periodic table, you'll see it's right on the opposite end of the periodic table now, number 17. How many valence electrons does it have? 7. So how many valence electrons does it need to gain in order to have a full shell? 1. So chlorine only gains 1 electron. Why only 1? It only needs to gain 1 to have a full valence shell. Okay? Yeah.
With valence shell, if you had like 3 left over, does it matter how you space them out? Or should you have like 2 together and 1 by itself? Or like
2 together, 1 by itself. Yeah. Yeah. Hey. Oh, sorry. Which one? Yeah, they do. So we're going to draw it in just a second. And we'll show how this works. Yeah. Sure. Okay. So, what we're going to do now is we're going to make an example out of these. And we're going to draw magnesium and we're going to draw oxygen. So when we draw magnesium, okay, we start in the center by writing Mg. When we draw oxygen, we start in the center by writing O. Now you've just done this. So I want you to draw the electron configurations for both of these again for me. Let's go. All right, let's have a look. So magnesium. We know that the atomic number for magnesium is 12. So how many electrons is magnesium going to have altogether? 12. And so we start by drawing our electrons in our inner shell. We have 2. In the second shell, we have 8. And in the third and final shell, how many electrons do we have? 2. Next, when we talk about oxygen, how many electrons does it have all up? 8. And we have 2 in the inner shell, and we're going to have 6 in the valence shell. So my question to you is this. When we look at magnesium right now, and we see magnesium, it has a full second shell here, and it only has 2 electrons here. How many electrons will it need in its third shell to be full? How many does it need to make a full third shell? 6. And my question to you, is it easier for it to find 6 more electrons or to get rid of 2? Get rid of 2. And so in this case, we lose 2 electrons. Why? So that magnesium can have a full shell. Okay? They want to be like the noble gases. They want to have full outer shells. When we look at oxygen, Okay, we can see that oxygen has 2 in its inner shell and 6 in its valence shell. Now, is it going to be easier for oxygen to gain 2 electrons or to lose 6 electrons? Great. So in this case, it's going to be easier for it to gain 2. And so what do you think these metals and non-metals do when they have a scenario like this? I want to gain 2 and I want to lose 2. They combine. And this forms a salt for us. This forms a chemical reaction. And this is why chemical reactions happen. Yeah.
If there's 4, what do you do?
If there's 4, then it might be a case of, as in there's 4 missing in oxygen.
Yeah, 4 missing.
Yeah. Then we'd need 2 of these. And then we could have 2 electrons from one, 2 electrons from the other, providing the 4.
No, but like if there's 4, do you lose or gain?
Oh, in the case of like carbon. So if you go to your periodic table, you notice that the other day we did +4 and -4. They can actually go different ways depending on what they react with. But as of a year 10 level, we really don't need to worry about it too much. Okay. So ions are formed when what? What's the only thing that is going to jump in this case? What's the only thing that we've been talking about today? The electrons. So ions are formed when electrons, okay, are transferred from the metal to the non-metal. And I'm going to highlight one key word here. Transferred. Okay. They're not shared, they are transferred. And when they're transferred, it means here, you can have them forever. Okay? Unless we break up, they're yours. Okay? So, I want you to have a go at this one. Let's read through it together. And this is going to do us for today. Okay? So, the sodium atom started off with 11 protons and 11 neutrons. It was neutral. Chlorine started off with 17 protons and 17 electrons. It was also neutral. Now, sodium has 11 protons, and because it had 1 in its valence shell, it loses 1 of its electrons, so it only has 10. It becomes Na+, meaning it has a +1 charge. Chlorine had 17 protons and 17 electrons, but it gained an extra electron, and so it becomes Cl-. Okay. What I want you to do is I want you to try your best to explain the charge that magnesium and oxide ions are going to have in terms of their protons and electrons. So I'm going to do magnesium for you up on the board, and then you're going to have a go at oxygen. So, how many protons, okay, I'll write a P in this box here. How many protons does magnesium have? 12. Okay. How many electrons does it have? 12. Okay. So when we're talking about the electrons, what is going to happen to them in an ion? Are we going to gain or lose 2? Lose 2. So if I had 12 and I take away 2, how many electrons will I have? 10. Okay. So what is going to be the charge? This is in an ion. So we'll go ion. Okay. What is going to be the charge of the ion? If I have +12 and -10, what is 12 take away 10? Plus or minus 2? Plus 2. Okay. So.
Wait, so does that mean you can just work out ions?
Exactly right.
So I don't have to study them. Can I have my periodic table?
You absolutely do need to study them. I'm very sorry. But using your periodic table, you will be able to figure them out.
Do we get this in the test?
You sure do.
Oh, and do we get...
You get that entire green sheet.
What's that one from memorising the table?
It makes you way, way faster.
At least he doesn't.
You'll run out of time if you haven't learnt your ions. Okay. So, I want you to have a go now at oxygen. Okay. I'll leave that little part up there. Can you work out what the ion is going to be for me? So in oxygen, we have 8 protons, so 8 positives. If I had 8 electrons and I gain 2 more negative electrons, it's going to leave me with 10 electrons. So 8 positive, take away 10 negative, that leaves me with an overall charge of -2. Why? Because if I have a positive 8 and I have 10 negatives, 8 of these will cancel out 8 of those, but then I'm left with 2 negatives on the side. So overall it will be -2. Yep. The number of protons is the same as the atomic number. So the number on your periodic table that's right up the top of the element. Yep. Question? Why is the bottom number a negative? Because electrons have a negative charge. Yeah. So let's have a go now, okay, at answering this question. Explain the charges of magnesium and oxide ions in terms of the specific number of, and here's the key part, protons and electrons. So we'll start off with magnesium. Okay. Magnesium has how many protons?
12.
Great. 12 protons. And when it forms an ion, it transfers how many electrons? How many does it give away?
2.
Great. So I'm going to write next to transfers, it loses 2 electrons. Okay. This means it only has 10 electrons left. So what is the charge of magnesium then? If I have 12 protons, 12 positives, and 10 electrons, 10 negatives, it'll be 12 take away 10 gives. So positive or -2 though? +2. 12 plus, 10 minus. 10 of the minus will cancel out 10 of the plus. Okay, but then we're still left with 2 overall plus. So this means it only has 10 electrons left. Therefore, the charge is +2. Okay. So one way that we could represent this, if you're still struggling with it, if I draw magnesium over here and I draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 positives, right? And I get my blue pen and I'll make it nice and big here. And I only have 10 electrons. So I go 1 electron, 2 electron, 3 electron, 4 electron, 5, 6, 7, 8, 9, 10. Those red and blues have cancelled one another out. What am I left with? 2 positive. And that is where this charge comes from. So what we're going to do now is we're going to write the opposite one. So we've done magnesium, okay? And our final thing today is oxygen. So oxygen has how many protons?
8.
Great. 8 protons. And when it forms an ion, does it lose or gain?
Gains.
Perfect. It gains 2 electrons. This means it now has how many electrons? We started with 8 and we gained 2, we have? Great. It now has 10 electrons. And if we do the same thing that we did a moment ago, if I have 1, 2, 3, 4, 5, 6, 7, 8 positives, and I get my blue pen, and we come through and we now have 10 negatives, so we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remembering that the first 8 are all cancelling each other out. What is the overall charge on oxygen going to be? negative 2. Okay, and so therefore the charge is negative 2.
Can you just do if it like if oxygen gains 2, it's going to be the charge of negative 2?
Yep.
Just do the opposite.
If oxygen gains 2 electrons, then it will be.
It's going to be negative 2.
Yep, exactly right. Okay. So the only thing is, when we write about this, what are some keywords that we need to include? I've highlighted them up on the board. You need to talk about protons. You need to talk about electrons. Okay. Now the big why. Why do they want to transfer their electrons? It is so that they can have a full what shell? Great. So the end goal of this is a full valence shell. This is why they are reacting with one another. Okay? That is the why. Okay? So that there